In this video, we want to talk about the conditions for circles to touch each other at x and y axes. But this video is specifically to show that when two circles touch the x-axis, equal roots are obtained. So let's begin. Now, in order to determine in order to show that equal roots are obtained when two circles touch the x-axis, you need to use the discriminant from quadratic formula, and this is the discriminant. B squared minus 4a is the discriminant. We say it is the discriminant because it determines the nature and then the number of roots that will be obtained from a quadratic equation, the nature and the number of roots that will be obtained. So it tells us that okay, there's going to be one root, there's going to be, and then its nature is going to be an imaginary root, or equal root, or whatsoever. So that is its main purpose. Now, what happens here is that we need to understand that the equation of a circle comprises the general equation, that is x squared plus y squared plus 2jx plus 2fy plus of c is equal to 0 comprises two quadratic functions or quadratic equations. One is along the x-axis and then the other is along the y-axis. Now, when one quadratic function or equation is established, a parabola is obtained. But when two quadratic functions are combined, that's one on the x-axis and then one on the y-axis, a circle is obtained. So you realize that a circle is just two parabolas combined. So that's why we have this general equation. So in dealing with the x-axis, we deal with the quadratic function on the x-axis. On the x-axis, in this case, it's going to be the x squared plus 2jx and then plus of c is equal to 0. Now, when this equation is compared to the general quadratic equation, that is ax squared plus bx plus c is equal to 0. We can establish that b is equal to 2j, and then also a is equal to 1. So that's what we can establish. So we can substitute the quadratic function of the general equation of circle into the discriminant to determine if indeed we are going to obtain equal roots. So from the diagram that we have here, we can see that the centers are AB for the first circle and then also A minus B for the second circle. So now what do we do? One thing that we also need to understand is that when it comes to the standard equation of circle, the centers are A and then B. For the standard equation of a circle, the centers are A and B, but for the general equation of a circle, the centers are negative J and then negative F. So for the general equation of a circle, negative F corresponds to B and then negative J also corresponds to A. So now let's substitute our equation into the discriminant. So from the discriminant, we know that B is equal to 2j. So we can have 2j squared minus of 4. We established that A is 1. So 1, and then C is still C because it is contained in both equations. And then this is C. Should be equal to 0 because we are dealing with equal roots. So here, what happens is that we have our 4j squared minus 4c is equal to 0. Now we can see that 4j squared is equal to 4c. Now 4 and 4 will cancel since they are spectators, and we have our j squared to be equal to c. Now from our equation of motion, we know that the radius squared is equal to j squared plus f squared minus of c. J squared plus f squared minus, let me write it very well, plus f squared minus of c. That's what r squared is equal to. Now we've established that j squared is equal to c, so we can substitute j squared into c, or we can substitute j squared for c. We can substitute j squared for c, and then the equation will become, the equation for the radius will become j squared plus f squared minus j squared. So j squared and then j squared will cancel. Then our final equation becomes r squared is equal to f squared. So we can take the square root of both sides. Then we have our r is equal to plus or minus so we have r squared is equal to plus or minus r is equal to plus or minus f. That is, we found the square root, we took the square root of both sides, and then since we are looking for r, so this becomes f squared becomes plus or minus. So that's it. Now, so here it confirms that the radius which is along the x-axis, which is along the y-axis, as we said earlier, we said that b is for f in the general equation. So you realize that we have this from the point where it touches the x-axis to the center, we have y coordinate to be b, and that will be equal to negative f for b. And then also from the same point, when it comes here, it becomes negative b, and then we know that b is also equal to that, so here too will be negative f. Then the negative and negative will cancel, so b will be either negative f or positive f, depending on the direction that they are moving. So we have established that anytime two circles touch the x-axis, equal roots are obtained. Equal root in the sense that if f is equal to 4, then it means that from the x-axis to the positive y-axis we have 4, and then from the x-axis to the negative y-axis we have negative 4. So this is what is meant by equal root. Thank you, and let's meet in the next video. Bye.